So let me get this out of the way. I decided to do some videos. I don't feel our class is working outside of my room. And so I'm going to do videos for you to do so. I'm going to start with, this is from Module 11 of Algebra 2. And then I will do Lesson 14 and then I'll work backwards from there. But this is very helpful to go over some of the stuff that you should know before Lesson 14. Let's start here on the top. So tangent, here's a circle, but tangent is sine over cosine. When we are using the circle, that is your y value over your x value. Secant is 1 over cosine. So it is the reciprocal of cosine. I know I'm just jumping in and this doesn't really go with that, but secant means you find cosine and then you flip it. Okay? You get the reciprocal. Cosecant, you would think that would be cosine. No, cosecant is with sine, so that's the reciprocal of sine. And remember, sine is y on the circle and cosine is x. And then cotangent, you flip tangent. So if tangent sine over cosine, cotangent is cosine over sine, which is x over y. On the quiz, a lot of people found tangent, just did y over x and then flip this one, and they ended up with tangent instead of cotangent. All right, find the exact measures of 4 pi over 3. Here is a circle over here. 4 pi over 3 is right here. So sine is your y value, negative square root of 3 over 2. Cosine is your x value, so I'm looking down here. Cosine is your x value, negative 1/2. Tangent is y over x, so negative square root of 3 over 2 divided by negative 1/2. Well, how do I divide that? That is negative square root of 3 over 2. Division is just multiplying by the reciprocal, so I multiply by negative 2 over 1 because that's the reciprocal. These 2's cancel. The negative times the negative is a positive, so all you're left with is square root of 3. That's the tangent. The way I tell people to remember is their negative divided by negative is going to be a positive, but this is your numerator, this is your denominator. There it is. Okay, cosecant is 1 over sine. So I get sine and I flip it. That is fine to leave it like that. You could rationalize the denominator, which I'll do that over here if you want, but it's okay to keep your answers like that. So that means we don't want a radical in the denominator. So I multiply by 1, but I put square root of 3 over square root of 3. So on the top I get 2 square root of 3, and the bottom, the square roots cancel because it's squared, and you get that. So this is equivalent to this. Secant is 1 over cosine. So I get cosine, flip it. Cotangent is 1 over tangent. So our tangent was this, which is over 1. So it's 1 over the square root of 3. Or cotangent, you could do x divided by y. So you could divide them and put this one divided by this one. So that's how you find those. I don't remember what lesson that was, maybe 12? Okay, so I want to go over the circle. You need to memorize this circle. We're not really doing degrees anymore unless you want to redo the first quizzes, but degrees aren't really used anymore, so we're using radians. You need to know that half of the circle is pi. You get back over here, and it is 2 pi. You need to know that each radius is 1, so this coordinate is 1, 0. This coordinate, 0, 1. This coordinate, and this coordinate. So you should know that in order to draw a sine, cosine, and tangent. I'm going to start with showing you how to draw tangent. I did this in class, but I will do it right here. 1, 2, 2. So one cycle is 2 pi around the circle once. This is 1. This is negative 1. Tangent. Tangent means we're going to divide. Remember, tangent is y divided by x. So if I come over here at 0, which is right here, 0 divided by 1, 0. All right, tangent of 0 is 0. I'm going to break this up to pi, 2 pi, pi over 2. This is quarters, 3 pi over 2, and the quarters. Okay, I'm going to jump over to pi over 2 because that's the next one here, and then we'll fill in the quarters after. Pi over 2 is 1 over 0, which is undefined. So at pi over 2, the graph doesn't exist there, so we do an asymptote at pi over 2. Then I'm going to jump to pi, and it's 0 divided by negative 1, so that's 0. I'm going to stop writing these. I think you should understand it. Well, I could just do this last one, but that's it. A pi is 0 divided by negative 1, which is 0. Then I'm going to jump to 3 pi over 2, which it doesn't exist because I'm dividing by the x, the 0. Then I'm going to jump to 2 pi, and it comes back to 0. Okay, those are just a few dots. Doesn't tell me how the curve is going. So now let's do the quarter. So half of a half is a quarter. So at the quarters, you're going to divide these numbers. When it's the same thing, it's just 1. Then I'm going to jump to this one. It's the same thing except for a negative, so it's negative 1. I'm going to jump to this one. Same thing, it's a positive 1. Jump to this one. Same thing, but it's a negative 1. So tangent goes along this asymptote and goes like that. It will not cross that dashed line. It just goes really close to it. Okay, that is your tangent of x graph. So these are asymptotes. These are your intercepts. There is no max or min because it is a wave. Okay, let's look at sine. Sine you should know by heart. I will show that you can see sine in the circle a little bit right there. So at 0, sine is y. Sine is y. Okay, so I look at my y values. 0. At pi over 2, it's 1. At pi, it's 0. 1, then 0. At 3 pi over 2, it's negative 1. At 2 pi, it's back at 0. Now, you could connect it like that, but here it's square root of 2 over 2, which is 0.7. So it does those. But sine, I always say sine is king because this is one period of sine, one cycle. So the period is 2 pi. And it has your max, and then it has a min. It's pretty symmetric in that, not that you could divide it in half, but you have the top part and then the bottom part. It's a full cycle for the 2 pi. Okay, so that is sine of x. Like this says x sine of x. So sine is your y value on the circle. Now let's look at cosine. Cosine, it actually looks more symmetric, but it's a little different because it's the x values. So remember our circle, I'm just going to do these. This is 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. So cosine are your x values. So at 0, it's at 1. You're going to do your x value. At pi over 2, because remember this is pi and this is 2 pi. Pi over 2, it's at 0. At pi, it's at negative 1. At 3 pi over 2, 1.5 pi, it's at 0. And then back at 2 pi, it's at 1. So one cycle of cosine looks like this. It doesn't start on 0, it starts on 1. That's a positive graph. If it was negative, it would start down here and go the other way. Okay, So let's look at the period of a function. So the period is how long does it complete one cycle, which is different than B because we've been doing this A cosine. I'm going to do just cosine, but BX plus C plus D. So this B, lowercase b, is different than period. Period equals 2 pi over b, and b equals 2 pi over period. Period is how long does it take to make one cycle. And b is how many cycles are there in 2 pi. Okay? So I'm going to write that right here. And b is how many cycles in 2 pi. And period, P, is one cycle. So this did one complete cycle in 2 pi. This one, we're going to find the period. So let's start on 0. So we're going to go up. When did we get back to 0? Right here, and then it repeats there. So this period is 3 pi over 2. That is the period. Okay? So we didn't, I guess we did do this one with the circle, with the Ferris wheel, the wall. So, looking at this. Henry set the record for the fewest pogo stick jumps in 1 minute. He jumped up and down only 38 times in 1 minute. His height off the ground, h, is a function of time. Suppose the highest point of each jump was 6 feet. Select the graph of the function. Now, this one doesn't make sense because it is the height goes underground. He didn't really go underground. He goes from 0 to 6, so it's not this one. So 0 to 6, 0 to 6, 0 to 6. All those are 0 to 6. Let's figure out 38 times in 1 minute. Okay? So, the other thing you could cross out is this one because time is your x-axis. And this one has number of jumps, so that one's not it. So 38 times in 1 minute. This is by minutes. If he does 38 times in 1 minute, then we're going to have seconds. So there's 60 seconds in a minute, and divided by 38, I bet you it is this right here. So it is A. Okay? I don't have the calculator right out, but I will check it just to make sure that that's how they got 1.6. 38, no, 60 divided by 38 is 1.57. So that's how they got 1.6. It's 1.6 times to do one cycle. So 60 divided by 38. That's how many times it took him to do one jump, or how long it took him to do one jump. Okay, so using the unit circle, oh, we didn't have to do those. Let's go to the exercises. The exercises, we just focused on these to find the period. How long does it take to do one cycle? So one cycle, if you want to pause and do them and then come back, that's fine. So pause now. One cycle, 10. One cycle, 6. Down, up, up, up. One cycle, 2.5 pi. It's not over here because we already have that flat part. One cycle, 2 pi. This starts slow, and it goes right here because that starts the new one. So one cycle is 4. Flat, not flat again. One cycle is 2 pi. So these are all the period. How long does it take to do one cycle of the graph? The next one we did was the moon. Oh, we did the Ferris wheel. So Ferris wheel with a diameter of 100 completes 2.5 revolutions per minute. The period, what is the period of the function? As described by the height of the C on the outside edge of the Ferris wheel as a function of time. So, this is just like that other one that we divided. 1 minute is 60 seconds, so you divide by 2.5, and it is 24 seconds per revolution. So it takes 24 seconds to get through one cycle, one revolution. Okay, the 100 feet and all that doesn't matter. They're looking for the period and how long does it take to start here, go around, and come back here. It does 2.5 per minute, but if you want just one revolution, it's 24 seconds. All right, the moon's orbit is the number of days it takes the moon to revolve around the Earth. The period can be determined by the graph as a percentage of sunlight reflected by the moon each day as seen by an observer on Earth. Use a graph to do the period of one revolution. Well, one cycle, if it starts here, to get back up is right here. So one cycle is 28 days. That's how long it takes the moon to get back to do one period. Okay? One period, which is different than B. B is saying how many cycles does it do in 2 pi. So if this is period, B is 2 pi over period. So B is 2 pi over 28, which is pi over 14. Okay, if we had to do the graph, that would be pi over 14. Okay. This one, the tires. Well, we know this is our A, so cosine usually starts up here, but it's going to start down here. Then it's going to add 8, so it's actually going to move up, but this is not with the D. This is D is 0. This is a D of 8. So what's the maximum height above the ground? It is 8. Are they inches? Height in inches, so 8 inches. What's the minimum height? Oh no, maximum is 16 because it's a circle. So you're on the ground, you're not below the ground, so it's 16 inches. The minimum height is 0, right? It's a tire cycling, so it gets to the ground. How many rotations does it make per second? 1 over 2 pi. So 1 rotation divided by 2 pi. How far does it travel in 30 seconds? It travels 20 feet in 30 seconds or 2,400 feet in 1 hour. And I think that's it for this one. That's all we did in class. Oh, no, we did the next one, which was this is a good problem. Okay, temperatures. So this is a good problem to figure out how to break it up into something else that's not really pi or that kind of thing. So we're going to do temperature in a city. T months of the year is the formula. So it is sine. So it's going to go up and then down. Now, I drew this like 0, but it is not 0 because it is 42. So this is 42. This is not negative 42. Sorry, this is 42. That's your D. It's usually over here after. This is 30, so this is 72 because 30 is your A. This is your D. So this is 42, this is 12. Okay, so that's the graph. I got that just from 30 and 42. 42 is the middle, 30 is the amplitude, the height, 12 is down here. 42 minus 30. Now, pi over 6, what does that mean? That's a b of pi over 6. So your period is 2 pi divided by pi over 6. What you do is you flip this, so it's 2 pi over 1 times 6 over pi. The pi's cancel. The period is 12. So it takes 12 months to do the whole cycle of weather. Okay? Because that's one cycle of sine. All right. What's the highest temperature for the city? 72. What month does it reach the highest temperature? Right here. 3. March. What's the lowest temperature? 12. I'm sorry, it didn't go to 12, but it is 12. What month did it reach the lowest temperature? Right here, 9. September. Okay? That was a good one to convert the weather. All right, let me know if you have any questions on this. If you need another copy, I could scan it in, or I do have a couple hard copies in class. Thanks.